Good afternoon. Check. It works. Okay. So I'm Vitaly Kamluk. I'm Chief Malware Expert from Kaspersky Lab. Okay, maybe we should stand here. And today we're going to discuss Duqu malware and specifically its CNC infrastructure, something that we discovered we're going to share today. And first of all, I have to say that all this research on Duqu and Stuxnet that we do in Kaspersky is just, we're doing that as a malware researchers, and there is no political motivation or any, government-sponsored stuff that moves us on. So it's done just almost, politically independently from any country, any state. That's why we're just, look at Duqu and Stuxnet as another example of malware. That's all. We are presenting together with Costin here. However, this presentation is made by 3 researchers. There is Alex Gostev, also chief security expert from Russian team. He's not here, so we're just 2. We are Linux fans, and I'm a power user and a fan of Debian and Ubuntu. So we have some background and experience working with Linux, which actually helped us during our research, as you will see later. Actually, here's photos of the rest of the team who actively participated in this research. However, the whole team, the whole group of people who was involved is much bigger than that. So, what is Duqu exactly? Well, first of all, it's a sophisticated attack, which seemed to be related closely to Stuxnet malware, and we will shed some light how it is related a bit later. And it was developed, it was active since 2008, and discovered only in 2011 by Hungarian research lab. So it seems to be used as a cyber espionage tool by some nation-state sponsored organization. Let's dive into similarity of Stuxnet and Duqu. Both malware, we think, are based on the same platform, and this platform called Tilted has the same components which are specific to this platform, and it is not present in any other malware that we have seen. These are 4 base components which were found in both Duqu and Stuxnet. First of all, it's a driver. They use a sys file with random names, like here examples of Stuxnet and Duqu names. Both of them have encrypted DLL file stored in a PNF file on disk. Both of them have another PNF file which is not an executable but an encrypted config file, big config file, also stored on the hard drive with almost random names. And both malware uses mini config stored as a binary value in the registry, also encrypted, which has a reference to the bigger config file. So all these things are pretty specific to particular malware, and we haven't found any other malware that uses the same components and approach. Another way of looking on these 2 malicious developments is the following. I suggest a game of binary similarity. Very simple idea that we applied during our research to find and understand why these things are similar. So this is a simple thing. We have a binary data, some random data here on the top, 0s and 1s. So we convert them into image. Very simple, bitmap. So black spot corresponds to the value of 1, and 0 is white. So from this data block, we get approximately this picture. So if we apply that to a group of files, here we can see 6 files. And now I want to ask you, the audience, from your perspective, which files are similar? understanding that actually the whole structure doesn't change. The particular parts of the file can be increased or decreased because of some code may be added to the section and something can be just removed. So it just shrinks or grows. So any suggestions? 2 and 6. Any others? 1, 3. 2, 4. By the way, let's try our hands actually and see how many people think, starting from 2 and 6. How many people think they're similar? 1, 2, 3. Oh, maybe about 10, 15 people. 1 and 3 who think they're similar? 1. Just 1. Any other opinions? Cool. Well, it just perfectly shows how technical our audience is, because when I asked the journalists, there were so many opinions. However, about 40% of them concluded that 2 and 6 are the most similar. And let's uncover what these blocks are. They actually stand for particular files. Some of them are benign, taken from Windows XP. They're drivers of approximately the same size. And 2 and 6, as you see, Duqu and Stuxnet correspondingly. So if we take a closer look at these two, if we just shift a little bit, you can see the obvious pattern showing the similarity of these things, which are pretty unique and is not met in other files. So that actually also showed us that these things are similar from this perspective as well. If we dissect these files and see what is there actually inside, you can see even the order of particular places in the file is kept the same. So the text strings, init data, and some DLL loader code for process injection, they are in the same position. Just they're the same as I told you, but some block can be increased and the other can be shrinked. Most of them have digital signatures, but here is the most interesting part: is the init data and the encrypted config file, which follows the init data. And encrypted config is embedded in the body of the malware, and also shows a strict relation between Duqu and Stuxnet. Because if we take that encrypted config embedded in the body and decrypt that according to the procedure, and actually this malware has different procedures for decoding both blocks, we see the very similar result. So if we extract the strings, actually the encrypted config is, when you decrypt it, it's full of zeros, and it has just 3 Unicode strings. These are the strings from those malware. The first thing is the registry path, where the value, which is the second string, is located, and that value is the name of the binary registry block having another encrypted part of the whole config. And the last string is the virtual device name that is used for communication between user space and kernel space. So, this is the P header of Duqu driver. Sorry, not Duqu driver, but one of the Duqu modules. And the interesting thing here is the link date. As you can see it here, it was linked in 2007 in August, which kind of shows when the attackers actually had some working modules already and probably started operating. And this is the timeline of the whole platform. So the modules that I showed you on the previous slide, which is dated late 2007, seems to be malware independent. It's part of the platform, but it's not specific to Duqu. So it seems like these modules were created in the first place, somewhere around 2007 or 2008. And then Stuxnet modules. Stuxnet Worm was created in 2009 and developed in 2010 as well. And only after that, Duqu malware appeared. And these modules, you can see here the dates extracted from the files that we received. Let's go further. We actually have a pretty long story on our website, securelist.com, and we had 10 parts of blog posts with all the details from particular stages of analysis. And this presentation actually includes most interesting parts from this research, as well as we'll show you some things that were never public, that were never published on the website. So I hope you find it interesting. If you have more, if you want more information about particular stages, you can check the website as well. So, who were the victims of this malware? We think there were about 5 categories of potential victims that Duqu attacked. It was power and energy industry, supply chain, shipment and procurement. It was military organizations and PLC design companies, certificate authorities, or authority. So they're mainly located in Iran. We collected all the evidence and all the sources, summed it up, and well, you can see here a chart, a diagram showing that most of them were in Iran. So it still remains the same, that Iran was the main target of both malware. So what's a typical scenario how victims actually get infected with Duqu? And the scenario is the following. First of all, I have to say that from our perspective, we think that there are just 3 companies in the world who actually put their hands on the real infected machine and got the real analysis of the infected host. One of them is us, and we are going to share some data based on our analysis. When we first added the signature for Duqu malware, several days later, we discovered that there is just one computer which reported about infection of Duqu, which looked pretty strange because comparing to Stuxnet, it infected like thousands of computers. And in Duqu case, it was just one, located in this country, in Sudan. It was not very easy, to establish all the contacts, to contact the national CERT team. However, we managed to do that. It took us some time, and the guys in CERT team were pretty responsive and pretty capable of helping us in locating the infected machine and getting the image. It was in Khartoum city, the capital of Sudan. And I have to say that Sudan itself is a pretty interesting country, and if you just go and Google for images using the keyword Sudan, you can find on the first pages something like this, and these, and these. So I think we were pretty lucky with getting the real information and finding the evidence of the targeted attack made by the attackers. This is how the Khartoum city looks like. We managed to find that machine, and it took us about a week. We checked all the possible ways of malware infection, and we tried to recover deleted files, so we checked here and there, and it really took us several days. We were looking first of all for the PDF with a zero-day exploit. However, what we found was not a PDF. It was actually an email with a doc attachment. So the Word document had the TTF parsing vulnerability, which allowed the attacker to get on the kernel level right after opening the document by the victim. It looked like this. The whole document inside had just one page with 5 questions related to some business operations and a picture. Picture was probably put there, to hide the encrypted parts of the shelled code inside of the document, to mix it with the JPEG information. And it actually looked very much like typical phishing mail, which works for many people, and is kind of already proved technology that using the social engineering techniques, making some business offer, asking questions and attaching documents actually works very well with marketing people. So the full cycle, after a user opened the document, you have a question?
Did they have to actually open the document in order to...
Did they open the document?
Did the email recipient have to open that document?
Yes, exactly. Actually, there were two mails from the same sender, and the first mail was ignored, and the second one sent on the next day was opened. So after opening the document, the vulnerability worked, and the code got on the kernel level and stayed there for 10 minutes, waiting for 10 minutes of user inactivity, maybe waiting for the user to leave the computer, and then it dropped the, it loaded the additional code and installed the service so that machine was infected after the reboot. Created the config files and the registry config value and so on, and contacted the CNC to load additional components. So after infection of the victim, what's next? The way it worked and the way it contacted, how we discovered actually the CNC and the link to CNC was the following. As I told you, Duqu malware has an encrypted PNF file on the hard drive. This is how it looks like, located in C Windows info folder. So just random data from the first site. When you decrypt it, you can see, maybe not very clear to see here, but it's a P file is MZ header, and it has a resource section .rsrc, very small text here, you can see it now. If you look into the RSRC section, we can see another section inside, which is Z data. And the data section looks like this. This is a compressed file inside of this section. If we decompress that, there is a plain text IP address embedded into the executable model, which actually links to the particular CNC. And this is how we found that. And then we follow the traces where the malware connected. We try to understand who operates it and how it works. So we got the IP address. What's next? The next is to contact the owner of the hosting company. This IP was, well, it's pretty public, you can Google it actually. And this one was located in India, in Mumbai. It belonged to a company called WebWorks. They had data centers, dedicated servers in Mumbai. So the whole idea behind it was to contact the owner of the data center and kindly ask to share the information we needed. Here are some more IPs that everybody knows. You can Google them, of known CNCs from Duqu, and some other unknown CNCs in other countries. You can see that they're geographically pretty widespread. And there were other servers which we found later, and this is a list of IPs and countries. Duqu actually used not just a single server to have the business logic in it, but the attackers built a chain of servers working as a proxies. So what you see here, the IP addresses, which are used as a proxies. And from our observation, we found that they used up to 3 levels of proxies, making a chain of servers to transfer information from one server to another. And we had to follow the traces, jumping from one server to another and asking for another hosting company to share the data. However, we didn't reach the source server, the final CNC, which actually had the business logics. But we extracted a lot of useful information on the way. And what kind of information? And the most juicy part, Mr. Costin Raiu is going to share with us.
Thanks, Vitaly. Can you all hear me? Okay. Clicker. All right. So, how do you get access to the command and control server, or to all these servers? And actually we have a couple of methods. And the one that we found that it's surprisingly efficient is just to ask nicely. So you write an email and say like, we're from Kaspersky lab, we're investigating this malware, so would you be so kind and give us access? And usually the answer is no. So you go like a second time and say, please, pretty please, can you give us access? And they'll say no. So you keep asking, a couple of times until you exhaust all the options, and finally you get to the point when you explain the threat, and you'll say, okay, so you have two options. You either work with us, or we'll send the police, or just that send the information to the police. Police will contact you, they'll take your server, and I'm sure that will be very pleasant for you. So that moment, usually, they give you access to the server. And actually we have a pretty good result here. Out of the 10 servers where we attempted to get the image, we managed to get the image from 6 of those, and from 4 of those we couldn't get access. And 6 of those actually provided some really interesting data, but I think that the other side of the coin here is that those where we couldn't get access. And if you're wondering, maybe you guys have some idea where the best bulletproof hosting in the world is. Any countries, any names? Come on. Netherlands, Russia, Ukraine. Nobody says China? China, Taiwan? No. Actually, it says Switzerland. And it's funny that, these people, they take care of their servers as good as they take care of their money. We had 2 servers in Switzerland. There was absolutely no way to get any information. They were absolutely denying everything. They deny the servers have anything. They even deny that the servers have OpenSSH on it, although you could connect to port 22 and see there's a secure shell server. They say, like, there's nothing on the server, go away. So, yeah, no luck. Anyways, from the other servers. So the first thing we noticed, which was very, very interesting, is that every single server was running CentOS. And for those of you who don't know, that's a kind of free version of Red Hat. And I thought I was curious that every single server was running CentOS. I thought that maybe there should be some who are running Ubuntu or whatever distribution of Linux Gen 2, but no, all of them were actually running CentOS, like 5.5, 5.4, 5.6, 5.3. 2 of them were 64-bit, all the others were actually 32-bit, so different configurations, quite different configurations, but they were all running CentOS. And they also have been hacked in 2009, 2010, and 2011, so that was the first time we managed to identify illegal access to these machines. And to analyze these servers, we used Sleuthkill, which is a pretty good tool. Then we created some of our own tools as well. We created some tools because we had to work with huge amounts of data. So we wanted to filter all that irrelevant data before searching it. So what exactly we were doing here was, we just get rid of all the empty spaces. Check. And then we'll extract the strings, we'll list all the deleted files on the server image, and we'll just plot a timeline, and then we'll start grepping for stuff. And here, it's important to know what to look for, because we're looking at like gigabytes of data, so you have to know what to look for. So we are looking for stuff such as accepted connection, or things such as UTMP, WTMP fragments, RSA private key, port 443 connections, and so on. So what did we find actually? Well, the first thing that the attackers would do when they would hack one of these machines, they would install OpenSSH 5.8. And that is important because CentOS comes with OpenSSH 4.3. So the first thing they would update to 5.8. So we asked some people in the community, like, what is the reason you want to update OpenSSH 4.3 to 5.8? And pretty much everybody said that the first thing an attacker does when they get access to a machine, they close the hole, which allows them to get access in the first place. So just close the hole so that other hackers, don't get to your server. Which is kind of scary, because in theory, Red Hat and CentOS, they come with a quite secure patched version of OpenSSH 4.3. And, well, They also did some other things. They would update the configuration files of the OpenSSH server, so they would remove two important options, the GSS API authentication and the use DNS option. So they would set them from yes, they would change them to no. And they did this on pretty much every single server. So we were kind of confused in the beginning, like wondering, did they actually use a vulnerability in the GSS API in order to exploit the servers? And after a while, we simply decided that this was done simply for performance issues, because we found that when these options are enabled, access to the server is much slower. Another important finding was that on October 20th, 2011, they logged into every single of these machines and they wiped those machines clean. And that is important because the news about Duqu broke, I think it was October 17. So it took a couple of days probably for this thing to, reach huge proportions. So at some point they took the decision they'll simply shut down the whole operation. So they had people logging into every single of these machines, cleaning them. Pretty much all servers, I think it took days, if not hours. And they were actually careful enough to use a shred command. If you don't know what it does, the shred command, before deleting a file, it will fill it with trash, with zeros, and only then it will delete the file, just, to make sure that the file cannot be recovered. But still, they did not take into account some very important things, the pitfalls of X3 on Linux. So when you delete a file using the shred command, first of all, you can still see which file was deleted. That information is kept. Secondly, deleting the logs doesn't take care of the slack space, so it doesn't take care of the files which have already been deleted. And remember that the logs, they get rotated. So that means that we can still find logs, from the past. And that was like very useful information. And finally, there are all these operations of file reallocations and truncations. These files, such as UTMP and WTMP, they grow and they shrink depending on people logging in the system. And when they shrink, the data doesn't get deleted. So based on all this information, actually we extracted some pretty interesting things from the command and control servers. And let me show you a timeline of such deletions from one of the servers. And basically the most important thing happens here. So on October the 20th, you can see there's like a spike in the number of file deletions. So obviously something big is going on here. This is a moment when they logged into the server to clean it. And there's also some interesting activity, prior to October 20th, which indicates that probably they were actively using the server for, pretty much the APT attack. And there's also an interesting event on 19th of July when they installed OpenSSH 5.8p2. And they also installed OpenSSH 5.8p1 on 15th of February. So I think that was a moment when this server was hacked. On 15th of February, they did a init.d cleanup and then they installed this server. There were other two very interesting events which we couldn't figure exactly what they were about. They were Duqu. Duqu is a IMAP server for Linux, and it crashed twice. So in the whole history of this server, it crashed twice. It crashed just before they got access to the server, and it also crashed somewhere in the middle of February. So in the beginning, we thought maybe they hacked these machines using a Duqu vulnerability, which we are still not 100% sure that it was not the case. But we have a couple of theories about how these machines were actually getting hacked. And the first theory is, simple brute forcing of the root password. And why is that? Because from one of the logs that you see here, there's like a failed password for root a couple of times, about 8 times. And finally, the 9th time, they get it right. And, here we thought maybe they're just simply brute forcing the passwords. However, what I tried, I recovered the shadow file and I tried to brute force the password myself using John the Ripper. So, tools which are a lot more powerful than trying to brute force the password by port 22 connections. And I tell you that, I tried billions of passwords and I couldn't break it simply because the password was strong. So that means this was not, the method they used. Another possibility was, as I was saying, OpenSSH 4.30 day. And there's actually some interesting discussions on the internet from people who are claiming their machines running CentOS with OpenSSH 4.3 were getting hacked. And now, there are different opinions, and some people say this is, just crazy, that all this, it's not sustainable. I mean, all of that is not really true. And in my opinion, that's simply too scary to be true. If there was a zero-day vulnerability in OpenSSH 4.3, that means that, maybe 50% of the machines of the servers on the internet would be vulnerable to this attack. And there is actually a third option, which I think it is the most likely. The third option is that probably there is another malware out there. So they were using another password stealing malware, maybe a version of Duqu, to infect some people, the sysadmins, and to steal their passwords. And then probably they had like a list of passwords for different servers which they were trying. So that's why you see 8 or 9 different failed attempts before they finally, get to the right password. So I think that maybe this is, the most likely explanation. And it's actually sustained by the fact that besides Duqu and Stuxnet, we found evidence of 3 other malwares, which are neither Duqu, they're neither Stuxnet. They're like similar to Duqu and Stuxnet. So what we have found is that during the development of Duqu and Stuxnet, they were like branches. So they created some other malware based on the same platform. Unfortunately, we haven't seen the malware itself. We've only seen the loaders for that malware. But based on the loaders, it is clear that there were some similar projects, some parallel projects to Stuxnet and Duqu. So at least we're talking of at least 3 other similar projects. So I think this is, the letters are too small for you to see. But the idea is that there are at least 3 other malwares besides Duqu and Stuxnet built on top of this platform. So let me show you some facts about these hacked servers. And one of them, server B, actually there was a very, very special case because we managed to get a memory dump. And the memory dump came from the live server. After the attackers cleaned the server on October 20, they didn't reboot it. So all these operations actually were still in memory. And we scanned the memory, and deep inside the memory dump, we found some interesting strings. What do you think? What you can see here is obviously you see the SSH 2.0 OpenSSH 4.3 banner, and this is an interesting server which was not used as a CC itself. It was used as a proxy, so like a jumping point. And this one was not updated to OpenSSH 5.8 for some reason. So what you see here is the OpenSSH 4.3 banner, but there's also some other suspicious information in here. Anybody can spot it. It's the sharp SSH banner, the second one here. So anybody knows what sharp SSH is? Let's Google it. So if you Google sharp SSH, I didn't know either. You'll find like, well, the first it is interesting. It says tired of sharp SSH bugs, so just try our solution. And the second one is actually the website of the developer of sharp SSH. So what exactly is sharp SSH? It's a secure shell library for .NET. So what does it mean? It means that the people who connected to this command and control server, they are using sharp SSH, which is basically a C# library. Okay, so that means that probably, they had a special need why they use this specific software. And in particular, if you look at the sharp SSH feature list, we find that it supports password and public key authentication, and most important of all, it supports stream forwarding. And it is exactly the stream forwarding they were using here in order to forward the traffic from these proxies to the backend. So for this specific feature, they used sharp SSH. The other reason why I think they use sharp SSH is simply because it was compatible with their already infrastructure, meaning that probably the infrastructure was in .NET. What about the guy who created this tool, Tamir Gal? I also, Googled him. Tamir Gal is a manager, a software developer. He works at a company in Israel. He has like a lot of specialty. He used to work for Cisco, has a strong background in networking and so on. My personal opinion is that he has absolutely no connection with Duqu. That's my personal opinion. I tried to add him on LinkedIn and ask him, but he didn't want to accept my invitation for some reason. But I don't think that he has any connection, to be honest. Well, anyways, so the main server of Duqu, I think it remains unknown. But we found some quite interesting clues here. And let me show you an example. One of the things we noticed from one of the servers were like hundreds of different logins. So this server had about 427 different logins throughout the time. So we thought, probably this is not manual, this must be automatic, and that is the reason why they use .NET. So the whole system, whole infrastructure is fully automated, right? So they have a daemon which reconnects to the server when the connection is dropped, and they forward the traffic automatically. So we looked at the login times. So here's like just some examples of login times on October 16, 2011. And we had the idea, let's try to plot the times, you know, to see exactly when this server was active. And we got some interesting results. What you see here is like this server was used in about 7 different campaigns. And each campaign, each targeted attack lasted for about 1 week. So it was used back there somewhere in March 2011, then it was used in May, in June, in July, August, September, and finally, here in October, you know, you see like a huge spike in usage. And I think this is the reason, you know, they were getting more and more confidence, so they started to use servers more and more actively to attack more and more targets, which is the reason why they actually got caught. But we had another idea. We had the idea, let's try to plot these times, you know, on a 24-hour graphic to see when these people sleep. Maybe it's not fully automatic, right? So what we got when we put that into a graphic, we got something like this. So I think this is a pretty clear indication this is not an automatic system. An automatic system, you know, will have like a flat line. So what we see here is that we have a bunch of people who go to work around 7 a.m. And here we're talking about GMT. So it depends. So they get to work around 7 a.m. Then they have some kind of a smoke break around 11. They have lunch at 2 p.m. I guess this is lunch. And then they go home. They go home around 6. And you see that when they get home, they also start working again. So this kind of really hard-working people here. And they keep working, you know, on a almost 24/7 schedule. So I think that's like not just one person, but multiple people. And here it's like a very good question, you know. When do you guys go to work? Do you go to work like 8, 9? Who goes, let's say, who goes to work at 8? A few people. Who goes to work at 9? More people. Who goes to work at 10? Yeah. So most people go to work at 9. So if we add, imagine that we go back here, 7, right? We put 7 plus, 7, 9, that's a difference of 2. So that means that probably the attackers were somewhere GMT plus 2, maybe GMT plus 3, it depends. It depends when they really go to, you know, to work. Maybe they go at 9, maybe they go at 10. So I think that's the probable location of these people. Another observation is that there were like 2-3 victims per command and control servers, no more. So they had like a pretty specialized infrastructure, and they didn't use one CNC for a lot of victims. And there were a lot of errors, disconnects, crashes, you know. It was, I think for them it was awful. It was almost a nightmare. If you remember what I said when I googled the sharp SSH, the first hit was tired of SSH, of sharp SSH errors. I tell you that probably these people are tired of sharp SSH, but I don't think they have like any good alternative. So there are many errors, there were like many waves of operations, and from these waves of operations we extracted some interesting information. Let me give you an example. So when they hacked the server, the first thing they would do, they would upload a script to identify what the server is about. So this script, which is a bash script, you can see it here, maybe you can see it, will do stuff like, you know, they'll list the uptime, they will list the root and home folders, check if it's virtualized, kernel version, CPU, memory info, they'll like a netstat, they'll root to Google, they'll do like a tracer to http://google.com. So, which is actually quite a funny thing. If you try that, you know, just try that on Linux. And what you get when you do traceroute HTTP, it says name or service not known, because it's not the right format. When you want to do like a traceroute, you don't put the protocol in front of that. So which is kind of a funny error in my opinion. So that never worked actually. I don't think it would work. And actually there are like more similar errors, more mistakes that we could find. And these are also examples that you can see from some of the servers. You see that they do a lot of IP tables, they just want to see, and then they do like OpenSSH -v, which doesn't work because that's not the name of the daemon. Then they do SSHD -v, then SSH -help doesn't work, it's not the right option. So they do open SSHD -help, then they do SSHD -h. Then they do an update, then they try very interesting command, yum install OpenSSH 5. That's because CentOS has OpenSSH 4.3, so they want to install version 5 for some reason. But this command doesn't work because in CentOS there is no such thing as OpenSSH 5. It doesn't work. So they try like yum search OpenSSH, doesn't work. Yum update OpenSSH server, doesn't work. Then they edit the configuration file, they try to use Pico. It doesn't work because it's not installed. They install Pico, they install Nano, and they keep editing and so on and so on. This is another very interesting example. They do some netcat, netstat, and then they do yum install rc-conf. That doesn't work. Then they do yum install rc-conf, doesn't work. Then they do yum search rc-conf, doesn't work. Then they do yum search rc-conf, doesn't work. Finally, and this is really awful, they do yum search rc space conf, which is tricky. Well, first of all, there is no rc-conf on CentOS, by the way. That's a Debian specific feature. And when you do yum search, don't do that, by the way. Yum search rc space conf, you get about 9,000 lines on your terminal, simply because it matches pretty much every single package which has rc in it. So that's like, you know, it's very messy, don't it? Yeah, this is what I tried. And this is also fun, in my opinion. Mon SSHD config. No idea what was going on. Here's another very good example. This is a lesson in using the FTP command on Linux. So they try, I can imagine what is going on here. Probably there's like two guys. There's like a boss and there's like, you know, an apprentice. So the boss says, you know, fetch the kernel from kernel.org and see how fast it is. So he says, yes, boss. So he goes and does vget kernel.org, which doesn't really work. So he says like, okay, remove index, and then he tries //ftp kernel.org/pop. Does not work. Then he tries man FTP, okay, so he said, okay, I need to put the -v option to see what the error was. So he does FTP -v ftp kernel.org, doesn't work because, you know, this one is extra. Finally, he does the right thing, but for some no reason it doesn't work. He checks the firewall again. Again it fails. Again it fails. Finally, he manages to get the right command. And now there is a reason why he's doing that. And here's how they did it in the script. So the script was probably developed later, when the you know, the guru got you know, fed up with the apprentice. So okay, I'll write it in the script. I put that in the script, and the script will simply do a vget to kernel.org/the kernel. And by the way, kernel 2628 was released in 2009, correct? At the end of 2008. So probably they did all this stuff at the end of 2008. Right. And now I'll invite my colleague Vitaly to take over and tell you a bit about the mystery of the Duqu framework.
Yes, there were several mysteries, and some of them were solved, some are still mysteries. So starting from the mysteries that we solved. Mystery of Duqu framework. So if you take a look at the payload DLL of Duqu, which has a real logics useful for attackers, it has several parts and some, you know, ROPs with the standard libraries from the compiler, from the Microsoft Visual C++ compiler. You can see here the, like, you know, the native C++ code with STL, some runtime library code and so on. But the biggest part, the payload is written with something completely different. There are no traces related to the standard libraries and the wrappers, and this code seemed to be not be very common for the C++ developers, and it has at all no links to the C++. So it seems to be written either in C language or linked and compiled and linked from some other probably unknown language. So these were two options that we wanted to check, and we were not sure because we haven't seen anything similar like that before in any other malware. So we asked the programming community to help us identify what is that, based on the some listings of disassembly and partly reconstructed pseudocode, which you can see here. This is how it probably looked like in the beginning. So from here you can see that it was probably event-oriented model and callback-oriented. So this is the style that was used to create the code of the payload. So we appealed to the community, and we got many responses, many opinions on that. People started suggesting, all these strange names of the programming languages we have never seen before. However, the most useful was a comment from this guy, calls himself Igor SK, probably Russian guy. He said that he is 99% sure that this is code produced by Microsoft Visual C with specific options for compiling to optimize size of the code and do not include inline functions. And this was actually the main version that we checked. So what we did, we took a part of the code again, and we tried to reconstruct the C code that actually stands for this assembly listing. And when we got the C code, we managed to compile with these options. We managed to compile and get exactly the same code. You can see here on the right what we got after disassembling the compiled C code, which we recreated. And this is actually the C code, which stands for it. So this mystery was solved, and it seems to be that the attackers used Microsoft Visual C version 2008 with optimized size and do not include inline functions. So with these options, it produced exactly the same thing. But that also shows that they have some custom framework with specific architecture that the developers probably enforced to use while creating the modules. So perhaps they even have a software architect. Some unsolved mysteries. There are actually several mysteries. One of them is just simple questions like how many CNC servers or proxies out there in total, and where is the central, the most valuable, most interesting CNC which has business logics. We didn't find that yet. Also, two unsolved mysteries extracted from the servers we analyzed related to the SSH and operations. We recovered a deleted known hosts file, which indicated login attempts on into two servers that you can see here. The server number 1 is ftp.unusualstatuecollection.net. What is that? How is that related to our guys? Well, and if you remember the Stuxnet CNC's domains, they were like mypremierfootball.com, todaysfootball.com, which kind of reminds of this strange name of unusualstatuecollection.net. And this is actually the front page of unusualstatuecollection.net. It's still up there, and there is no obvious relation why it is there in the known host file.
And Vitaly,
Yep.
it's in Switzerland, right?
Yeah, and it's the Switzerland server, Swiss server. So, yeah, we couldn't actually get the image and check ourselves how it is related. The other server was ftp.ubuntu.com, which is pretty strange. We are not sure if that's real or not. We are not certain about the relation, but it looks pretty scary, I think. If this guy actually logged in from the one of the compromised servers into this server, that actually poses a pretty bigger risk than we initially thought. So it's still a mystery how it is rated. We contacted Canonical and asked them to check that, and they actually confirmed that they had the SSH, public SSH key that we had found in the known hosts file, and that server was up. However, it was erased, and we couldn't get an image. So, but still, it was up there, and the bad guys, the attackers, they probably connected and logged into that server. So, this is actually the end of our presentation, and we hope that this light bulb brings you some enlightenment on the topic of Duqu and Stuxnet. Thank you very much. If you have some questions, we have maybe 1 minute to answer, so please shoot. We will also be available after the presentation at the coffee break.
Yeah, who do you think, based on all those errors that they made, who do you think the people are running this botnet?
Who do we think these people are?
Yeah.
Could you be more specific? You mean the...
Based on the application, based on whatever they're doing with it, right? What are they doing? Denial of service, right? It doesn't seem like these people are very skilled.
No. So actually, probably you missed the beginning of the presentation, or maybe we didn't explain it clearly. But this is a nation-state sponsored attack, against mostly Iranian targets. So, that probably gives you an idea who the people behind the attack were. Whoever has interest to spy on Iran at the moment. So there are not so many options. And actually, what I think here, and this is quite normal. All these mistakes that you're seeing, these are pretty much normal. And the reason is that how it happens, in the normal life, you have your best people, like from attacker's side, are tasked with getting access to the machines. So they are the ones who hack the machines. Then you have the lower people who do the hard job, like exfiltrating the data. So those are people who don't know how to use FTP, don't know how to use VGet. They pull up man pages for man, and so on. So this is quite normal, I would say, but it indicates that they're also normal people.
That was my question. Thank you.
Welcome.
I think we have time's up, I think. So,
Time's up.
yeah, if you want to continue conversation, please, we can do that outside.